Acyl chlorides are useful reagents in synthesis. They react with aromatic compounds and also alcohols. CH3CH2COCl reacts with benzene in the presence of an aluminium chloride. It's going to be our catalyst. It's going to be electrophilic substitution, it's telling us. It says that they react together to form the electrophile. So let's do that bit first. So what happens is the aluminium chloride is our halogen carrier. It's going to grab the halogen, so take off the Cl, make AlCl4-. That's going to leave us with a positively charged carbon that is our electrophile. And then we need to do the mechanism. So we're going to draw a benzene ring. And then we're going to draw, I'm going to turn my electrophile around because the positive end would be attracted to the high electron density of the benzene ring. And then out we go. We're going to pick up our electrophile. And now it's important that when you draw the horseshoe, I'm just going to tidy up this hexagon a little bit. When you draw the horseshoe, that you are open where you've attached the group. So at carbon number 2 to carbon number 6, we're going to draw a horseshoe. And then we're going to put a plus in the centre. Then the bond holding the hydrogen on is going to break and put the electrons back to reform the benzene ring. And we've created our product. So it told us that product, so let's just redraw it, which had this, can be converted into this alcohol. So we're reducing a ketone to an alcohol. We have to give the name of the alcohol. So since the alcohol is the main functional group, the carbon with the alcohol is going to be carbon number, well, it's going to give the smallest numbers closest to the alcohol. So it's propan-1-ol. Okay. But it's also got this benzene ring attached to carbon number 1. And when we attach a benzene ring, we call it phenyl. So it's 1-phenyl propan-1-ol. Now the reagent needed for this reduction is sodium borohydride. And the name of our mechanism, it's aldehydes and ketones mechanism, it's called nucleophilic addition. And then it says that the alcohol can react with ethanoyl chloride, CH3COCl, to form an ester. Okay, so that's where we have like R, C double bond O, R dash, like a different R group. What would you see? Well, because we're using an acyl chloride, then our other product will be HCl. So we're going to see steamy white fumes of HCl. And the mechanism that acyl chlorides undergo is called nucleophilic. So the alcohol is the nucleophile. It adds to the acyl chloride, and then we eliminate the HCl. So nucleophilic addition, elimination. So our acyl chloride loses the Cl, and we're going to add the alcohol. Now, just remember that structure of that alcohol had a prop chain and a phenyl group. So it was attached to a 1, 2, 3 chain that had a phenyl group on the first carbon. There we go.